Now what will be the capacitance of this system? This will be K1, K2. Let the distance be d by 2, d by 2. What is the effective capacitance? Cxy. Then when I send a charge, the charge or when the same charge will flow, no? So they are said to be in series. So this is equivalent to two capacitors xy, c1, c2, k1, k2. So how they are parallel. So then what we write is 1 by cxy equal to 1 by c1 plus 1 by c2. This is equal to 1 by k1 f naught a d by 2, k2 f naught a. So this d by 2 epsilon naught a you take outside, 1 by k1 plus 1 by k2, or cxy should be equal to epsilon naught a 2 k1 k2 by d k1 plus k2. If I want to replace this with an equivalent slab, what should be the dielectric constant of that? Should be 2 k1 k2 by k1 plus k2. This is equivalent dielectric constant. F naught a by d. So if I want to replace these two slabs by one equivalent dielectric slab, what should be the dielectric constant? Not k1 k2 by k1 plus 2 k1 k2 by k1 plus k2. Similarly, if they are connected in the either way like this, what about this? So the distance of separation is d. Half of the area this will take, half of the area this will be a by 2 and a by 2. If a charge comes here, it will branch out. Then these two capacitors, they are in parallel. So here K1, K2. The distance of separation is d. What is the area of cross section? A by 2, a by 2, and this a by 2. So therefore, what is the effective capacitance? Cxy. In this case, it will be C1 plus C2 directly. So K1 epsilon naught a by 2 d. So effective capacitance, this should be equal to K1 plus K2 by 2. If I want to replace this with equivalent dielectric slab, the dielectric constant of that slab should be K1 plus K2 by 2. So like this, some combinations, and you look at this, this is a very popular.